Good morning, everyone. Thank you for joining today's session. This is Teresa Thomas, and I'm here to introduce you to the speaker of this session, Subhash Ilago. Subhash has 24 years of experience in product design and solutions around ERP and data. During this time, he not only worked on numerous complex data projects, but he was also instrumental in architecting, designing, and building the ChainSys data platform. So please join me in welcoming Subhash to discuss the ChainSys Data Management Platform technology.
Hey everyone, good morning, good evening. So I'm Subhash. So I've been with ChainSys for the last 20 years. So been most of my journey here. So today we'll see more about the ChainSys data platform and the technologies that give you the power to do whatever it has to, right? So the agenda for today, like, it's more about data management. Right? So we'll see what is data management, and then we'll see how ChainSys data platform helps you with technology and process to guide you and help you in achieving what data management has to achieve, right? So we'll go through the ChainSys data platform, then how data integration as a part of data management is going to work. So we'll go one by one. So now, what is data management? There are lots of definitions that can be done, but as a simple term, like data management is just to keep your data organized. You need to organize your data to make sure the data is accurate, consistent, and easily accessible and secure. So these are the four fundamental characteristics that has to be there for a data, right? To manage your data. So accuracy, consistency, accessibility, and security. So from a data management process perspective, right, there are 10 basic steps or 10 basic functionalities that is important. Right? So to start with, we start with the data architecture. Every company or every organization will have a certain goal, and we need to start working towards architecting your data structure towards that goal, right? Like, you cannot have a common architecture which will go give every single organization the same architecture is not going to help. Like, every organization is unique, every data structure is unique. So we have to architect in a way that helps the organization. And then comes data modeling. So data modeling is basically to give you more power to analyze and report on the enterprise level. Like, it's not on a system by system basis. It has to be on an enterprise level, right? So how do you do a data modeling? So unless until you have a clear idea of what you have in your data architecture, you will not be able to do a data modeling. So data modeling would be a second step. So once you have this, then you start data integration. So data integration is one of the most important component there, right? Like, you will have data across different domains, different applications. How do you integrate all these data to show a meaningful report, or how do you give meaning to the data that is scattered all around, right? So data integration is the key to manage your data. And then once you have, let's say you consolidate, or there are different methodologies to do the data integration. So once you have the data integrated, like, how do you know what is the data you have? So you have to have a metadata management to understand how the data from different domains or different sources act, and then start working towards the processing the data, I would say, right? So that's on the metadata management. Once you have a metadata created, then you start working on creating master data and reference data, like basically master data management. So you will have here, master data management just does not only talk about creating master of data. Like, you need to have data cleansing, data quality will also become a part of your master data management. So it cleanses your master data, create references for further integrations and downstream systems, right? So basically we call this get clean portion of it. So you make your data clean. That's the first step towards making your data better, right? So you'll be doing a lot of enrichment on your data. Right? Once you have the master data centralized, like, then you start working towards your data security. Right? When you talk about data security, it's all about your who has access to what, and your GDPR compliance, or all your data masking, and all these things would start falling in place. Right? So, but until you have all these steps created, working on the security would be like working on that structure would become difficult. Right? Once you have this, then we start working on the data analytics part of it. Right? So you start making, you right now will start using the data that you enriched, cleansed, everything, to start giving the business what they would like to see. More analytics on it, more business intelligence reports, all that comes out of these data, right? Then you also start on unstructured data. Like, unstructured data is again a bigger piece of it, like where you when I talk about unstructured data, it's also your content management and so on, right? So you start uh, creating profile the unstructured data, make sure if possible convert it to a structured data, or at least link to a structured data, and make sure that the unstructured data is accessible through all the structured data possible, right? And then the data quality management. We have already started working on data quality management when we started the master data management, right? But this data quality is for, unless until you don't have a control, you don't govern it, like your master data may not always be the same, your data quality may not always be the same. So you have to start monitoring the data quality on a day-to-day basis, so that your quality does not come down. So you will have to set policies to make sure, you have to set metrics to make sure your data quality always stays to a certain level, right? So that's the data quality management. So basically, we say when we do clean, then stay clean, right? So that's how we call it, ChainSys: get clean and stay clean. And then you go to data governance. Then you start working about once you put this in place, like you also sometimes start with data governance to understand what you want to do with your data, right? But your data governance is not a static one. It's just not a one-time information. You have to start once you have your initial data governance done, you have to start constantly looking at your data, looking at the growth, business growth, everything in put together. You may have to keep revising your policies and revising your metrics to make sure your data is to the best possible quality, right? So as a whole, this whole set of 10 principles constitute a data management, right? So how does ChainSys come into play here? So ChainSys, we have a platform. The platform does everything that we have discussed about, right? It helps you do everything that we have discussed about. And we'll start one by one. So I'll just start with what is the ChainSys data. Okay. So if you see whatever we discussed earlier, we have the same structure, right? You have your all your source data, different types of source data. It could be structured, unstructured, or from sensor images or videos. From there, you start your data ingestion, which is nothing but your data integration part of it. Create pipelines to just data, and then get through it into a storage. It could be any big data or NoSQL data, and get it into the data storage part of it. Then start the active metadata management. So you do the metadata management, make sure you understand the data, unless until you understand the data and make sure that anyone who sees the data understands it, it doesn't will not really take us to the end goal, right? So we have to understand the data, and then start on working on the data security, to understand what are all the PII informations that needs, create workflows to make sure there is approvals happening and take on the security is taken care of on the data, right? And then start working on the analysis part of it. So I think we've already gone through. I'm just reiterating that ChainSys platform helps you go through exactly the same structure. And if you see in the bottom, the data governance and master data management or the data quality is a journey all through it. Like it doesn't say, okay, you do a data quality here and then go. It runs along with all the process, right? So, and then you have your data visualization and how business consumes it, right? This is the whole. Just as an introduction, we have ChainSys as a smart data platform. So we have split our platform into two. One is the data platform and then the business platform. So data platform mostly deals with your data side of it, and then your business platform is more like your front ending side of it. How you want your business platform, like business to look into it, right? So you have DataZap, which is more your enterprise data movement solution, I would say. And then DataZen, which is more your data quality and data master data governance side of it. And then you have DataZens, which handles your cataloging, analytics, security, basically giving sense to your data. That's the reason of the name Zens, right? And then comes to your coming to the smart business platform. We have something called smart bots, which is an business process automation engine, and we sometimes use even these bots to load data or ingest data, right, into the applications, which we'll see in the upcoming slides. And then we have the smart app builder, which is a low code, no code platform with which you can build applications over the data and then display it. So this is like there are multiple use cases. Like you can archival is one example. Like you do an archival of data and then use smart app builder to create an application to search or to look into it, and still you reduce the hardware cost on the existing run and also improve the performance. So archival is a very good example where we use the entire platform from the DataZap and Smart App Builder together. Now let's get into the data integration side of it. So data integration, as I was saying, is one of the most important process in the data management journey. So what are the current challenges in data integration, right? So you have data coming from disparate systems, and then you're not sure if their data quality is a problem that you'll have. You'll have format issues, duplication issues coming in, then a lack of knowledge on the available data. So sometimes we've seen situations where the legacy application has been there for years, and there's no one who has it's running as a whole, but has no clear information or knowledge on the data as such, right? So that's also a problem. And sometimes you have data availability, like latency or accessibility could also be an issue, and scalability. Like as your business grows, as the data grows, how is the scalability of your integration going to be? Right? So that's on the challenges. So basically, the techniques that we consider 4 different techniques for data integration. So data consolidation, like or the middleware data integration is one part of it, which is basically bringing all your data into a staging kind of thing and then moving it into the appropriate warehouse or something. Right? And then data propagation is basically your application-based integrations where you move data through a middleware or like basically it's kind of a real time. The application pushes the data, propagates it to the downstream systems. Right? So that is one type of integration. The common storage integration is mostly used, I would say, is the most approachable integration, where you consolidate all the data into a data lake, right? And then start manipulating your data and start giving the reports to the business users. So you can constantly keep moving, like you don't have to go to each and every system to bring in data. You bring it into one single area and start using the data. And data virtualization or uniform access integration is the next methodology, where you don't create that bigger data set into a data lake, but start pulling data from multiple systems and then do a uh, like integrated with just data coming from different disparate systems. It has its own limitations. Everything has its own advantages and disadvantages, right? So we'll go through that one by one. So, but today we'll be more seeing on the common storage integration. All right. The solution you can see in the bottom, that the solution that we've seen, right? So you start with taking data, basically acquiring data using the extract adapters, right? And then it starts profiling those data to make sure you understand the data and then start working on the data quality, right? So here you do an assessment, basically assess your data with all different validation rules and say how qualified your data is, and then do duplicate checks and then enrich or validate your data, right, before you can move it into the data lake. Right? So then we do the master data management with match and merge, make sure all your duplications are taken care, your data is standardized as per your metrics that you have created, and transform the data as needed for the data model, and scramble or encrypt is basically to secure your data. So we'll talk more about security in the upcoming. And then once you have this done, you have a workflow created to make sure the data that you've created is verified and made is approved to take it to the next level and then start ingesting into the data lake. You got to have these processes to make sure your data is clean. So once you have your data into the data lake, then you use it to catalog it or to create analytics out of it. And so here we've just given you an information on, as I said, it's a common storage integration methodology where you move your data into the data lake, and then from there you start creating your enterprise data model to show your analytics. Right. So we'll see the next slide would be to show you how we built DataZap in terms of the architecture to handle this. So you can see on the left-hand side all the different endpoints that it can access. So you have relational databases, enterprise applications, cloud applications, enterprise applications like Oracle EBS, SAP ECC6, and so on. And then you have cloud applications like Oracle Cloud, Procore, SAP S/4HANA Cloud, and so on. And then you have big data lake as endpoint, NoSQL databases, enterprise storage systems like G drives, OneDrive, Box, and so on. Right, and then you have your message broker like Kafka and other things. Right? So if you could see here that we've split this into two parts. One is the execution engine, and the other one is the execution controller. Right, so you'll know a little bit more about this when we go into the hybrid cloud deployment model. But basically, everything is a microservice created, so that the way we've designed is like we have microservices created for most of the components, so that it's not just a, let's say, it's DataZap is not just a product. Okay? It's a solution, I would say. So it's not just DataZap; it's a combination of Zap, Zen, and Zens together would give you a full-blown solution. And you need not use the entire components in the platform. You can choose and create your own solution. Also, we'll come up with all the standard solutions, which most 99.9% of your time will be suffice. But if at all you need to create your own solutions, you'll be able to still do that, right? With a smart app builder as a part of it. And so on the execution engine, so we have your endpoint connectors where we have all different types of these are the basic connectors, I would say, right? After using these basic connectors, we have created connectors for each and every endpoint. Let's say for Oracle EBS, SAP ECC6, or SAP S4HANA, and Procore, and so on. So every endpoint will have its own connectors. If at all there's not a connector for a particular system, for an unknown system, or for a system that we haven't created a connector yet, you still will be able to use the default connectors like the OData connector or the REST APIs or the SOAP services. You'll be able to use these connectors to get connected to the endpoint to move and to pull and push your data. Right? So the flow remains this way, right? You start extracting the data from your endpoints, and then in your extractions, it's so we have the CDC engine to make sure you have an incremental data flow, and then you have filter engines, you have child iterators. There are situations where you will not be able to handle that larger volume. Let's say you'll have only a certain set of volume that can be extracted in one time or pushed in one time. So you can create child iterators where you take the data, iterate it, and then get more data out of it. Right? So that's option. And then we have a crypto engine to make sure your data is secure. And then we stream your services. This is highly used in for data exchange, which I'll come back later. So basically, this will stream your services and give it to your end users, right? So this is on the data extraction side of it. And when it comes into your data flow adapter, before going to the data flow, I'll have it in the come to the loader and then go into the data flow adapter. In the loader adapter, you start with an ingestion engine, and then you again have a crypto engine which takes care of your data security side of it. And then you have a passive transformation, which is more your lookup transformation, sequence transformation, or expression transformation. And we also have something called TAPI, or transformation API, which basically create a transformation in one place. Let's take an example as once you do a customer transformation. After you finish your data quality, master data, you get references, cross references out of the data quality that you have created, right? So now you'll have to you'll be doing your transformations out of that reference data, right? So or the cross references. So you don't have to create cross references for the customer in each and every object, like invoices, cash receipts, and so on, right? So basically, you create a transformation API in one place and start reusing it in the multiple loader adapters that you have, so that if you have to make any changes, it's just in one place that you are going to do, and not in each and every loader adapter. So similarly, we have a validation engine where we have lookup transformation, lookup validations, and expression validations. And again, here we have something called the validation API, again for the same reason. So you do a validation in one place and then make sure the same is being used in multiple places. And then we have the reprocessing engine to handle all your exceptions. Basically, this is nothing but your exception handling engine. So if you have failures, you have different options to reprocess. And then finally, the reconciliation engine to reconcile the data. There are two types of reconciliations that we have in the platform. One is the functional reconciliation and the technical reconciliation. So by default, your technical reconciliation will be part of your loader adapter, where again you will be able to reconcile between the source and the transform data and the transform data and the end data. Okay, so that's on the loader adapter. So once you have a loader and extract, so we have the data flow adapter where you will be able to do an active transformation where naturally you'll not have the same structure in two different applications. This is more for an application based integration, right? So or data propagation integration, right? So for those places you'll need your active transformations, or even let's say for your common data integration, where you have a structure created in the system. So we will have to do the transformations in terms of structures that is needed, right? So for that you have multiple active transformations, and then we have the mapper to map data between these source and the target. And the most important thing is we have it all templatized, that it's not just we just don't give a bare metal, right? It's not just a bare body. So we also give templates for each and every endpoint adapters, like all the enterprise applications, like SAP, Oracle, Procore, and so on, right? So here again, like it's not only your extract adapters and loader adapters are given as templates, even the data flow, basically your mapping is also templatized, so that you don't have to do something for all the standard mapping. For any customizations, naturally you'll have to go and make some changes, but I would say 80-85% of the time, or 85% readiness would be there. Maybe 15% of adding more transformations and validations, and a little bit of transformation, active transformation may be needed. That's on the execution side of it. And then you have your controllers, basically, which is going to trigger all these informations, trigger the data movement from the controller side of it. So you have your migration flow. Basically, the migration flow is moving from one system to other system. Let's say you're moving from Oracle EBS to SAP S/4HANA. You have a standard set of migration flows to help you on the migration. Again, migration is not just a movement of data; it's a process by itself, right? It's how you process your data with all approvals and metrics that has to be created. So all those things are part of the migration flow. And then you have your process flow, where you orchestrate all your integration needs are done on the process flow side of it. And then you have your reporting engine, which we use our internal visualization API, which you'll be seeing later. And then we have the reconciliation adapters. Your API gateways are nothing but, let's say you have a legacy system which needs to be integrated with an external thing. So where you want to publish the loader as a either the loader or the adapter or the entire flow itself as a REST API for a webhook call, you'll be able to do that, right? So you'll be able to publish it as a REST API or a subservice. And then you have data exchange. The data exchange is nothing but it's a part of the data governance also. We keep it in two ways, right? So we can monetize the data by saying, okay, I have the data exchange created with all governance put in place, and this data exchange is published to external people for sharing your data. Right? It's sharing your data with all the restrictions and things. So that's your data exchange. And then you'll have your schedulers as part of it. I don't think we need too much of explanation on the scheduler side of it. And then you have your versioning engine. The versioning engine here is nothing but you don't have to do everything externalized to the platform. You have everything internal to the platform, where you can version all your object configurations, and then use this versioning engine to check in, check out into the subsequent instances, like from dev to SIT to UAT to prod. So you'll be able to do it within the platform itself, which gives you more advantage, because there are lots of manual process which is being eradicated because of that. Right? And with respect to the scalability, I'll come back again on the scalability side of it, because each and every the whole service can be replicated, so that you have a high availability, or it can become scalable by creating multiple instances of it, and then start using the load adapter to, or the data load balancers to call each and every service. So once you have the data integration in place, actually, as we saw in the first slide, data quality is not outside data integration, right? So data, the one that we saw is more towards data enterprise data movement side of it, right? But data quality becomes a part of the process, right? So what are master data and data quality? So what are the challenges right now, right? So basically, model agility. It's like you cannot have a very constrained set of model saying, okay, this is my model and everybody has to adhere to it, right? You need to have uh, freedom to create models, and also have freedoms to update it as and when necessary. It cannot be rigid. That's one challenge that is there in the industry. Then you have data standards. How do you standardize your data? It's a general problem that's there. And then data governance. I think you've seen what data governance is, and then data quality integration as part of your master data management, data stewardship. Without data stewardship, I don't think you'll be having a clear data. And then you have your UI augmentation. Not everyone will be comfortable with a certain set of UI, right? So we also give you option to augment your UI and make changes per person, or I would say per user group, right? Like so that is also possible. So that's a challenge, and that's how we solve it. Basically, our solution would look like this: like you have a clear data filter, assess the data, match and merge, and then cleanse. Right. So I'll go through the next slide, which explains how we do it. So, see, as you see, we always try to reuse our components internally, right? So as a platform. So to go and fetch data from multiple endpoints is not an issue, because we have the DataZap as a service which will be used by DataZen or by the components to take the data as input, right? Once basically that's your inbound engine, and then you'll do a mapping, and then you'll have an outbound. So that's your integration engine inside DataZen, right? And then you have the profiling engine, which calls DataZens, which we'll also see in the next few minutes. Profiling engine basically is profiling your data, making sure that you understand the data even before you start modeling it, right? So you need to profile your data, understand your completeness, your uniqueness, and so on. So all those things are done using the profiling engine. And then we have the data quality engine, where you can build your own rules and profiling engine. You have your cleansing engine. Here again, the cleansing engine is not just some rules to do a cleansing, but it can also go talk to third-party APIs to do standardization, like Google Address or USPS, Dun and Bradstreet. So you'll be able to use these external third-party APIs to do the data standardization or data enrichment. Again, you can set rules saying if this needs to be approved or it can be a default one and so on, right? Then naturally you will have your harmonization engine to consolidate all your data and then do deduplications and then do it, right? And then your standardization engine. So that's on the data quality side of it. And this is basically your get clean engine, right? But once you have your get clean engine, you have to make sure you always stay clean. So basically we use the same rules and standardization engines to create a flow, making sure that everything goes through it and makes validation out of these quality engine, and then goes through an approval to make sure your data is always clean before it hits your master hub, right? So basically we have different hubs created, a request hub for any requests coming in, and then you have a quality hub to do all your quality side of it, and once your quality is done, you have your master data hub. That's how the process goes. And then you have your metadata management and cataloging as part of the platform, right? So here you can see that again, I've put it in this way, like what are the challenges that we have and how we are giving solution to it, right? The current set of challenges is missing the metadata relationships. You do a profile, but how do you create your lineages between multiple systems, right? Data citizenship. Without data citizenship, it's difficult to make sure that you give sensitive data, be creating business glossaries or creating your relationships. All these things needs a data citizenship, a business user. Unless you bring the business user as part of the metadata management or cataloging, it becomes too difficult for you to handle it. And data security again is a problem. So I think these are the common problems which we have also. Unstructured data. So what do we do with unstructured data? How do we do the metadata out of it? Is a big question mark that we have, right? And how is the technology going? See, it's just not going to, profile alone is not going to be enough. You need to do a profile and do a machine learning process to understand your tagging concepts of it. So you need to tag or create business glossaries. So you cannot give everything to the human to say do it. You have to give learn and then start suggesting and making sure that we automate as much as possible, if not 100%, but practically whatever possible automation is there is going to help make the metadata management success, right? And then not just profile and ML, also start using analyze the content with an NLPs, particularly on unstructured data, right? To understand, for you to even say, okay, this particular unstructured data or this particular file is related to this particular structured data, is something that we need to start working on, right? So you need to start analyzing the data with NLP. Right? So basically our solution goes again this way, like we have your configuration where you have your structured and unstructured libraries created. Then you start business track wise profiling, and then we can do a full set of profiling, but sometimes we going in a piece by piece basis may help. So you start profiling business track wise and create all these multiple profiles of business track wise profiles of multiple sources into a group to create a heterogeneous library, right? And then start executing it. So during the execution process, you learn what is the metadata out of it, and then during the process, you also understand what are the PII data classifications. Basically, your understand your PII and classify the PII out of it, create lineages and entity relationships, and then do a basically index all your data, the content as such, right? It's not just metadata, index the content to make sure that you will be able to you give the users the ability to browse for data and show them where that particular data lies. That's on the catalog execution side of it. And then you have your data stewards, owners who can start working on your the registration is nothing but your business glossary. Okay? So register your business glossary at table level or field level, and make sure that lineages are being approved, and so on. Right? So that's the overall strategy that we have. Coming back onto the technology, so we have a structured profiler where we have the metadata engines, sampling engines. We do use sampling engines if needed, and relationship engines to create relationships between the source, between same source. And then we have unstructured profiler where again we have the metadata engine. We have form-based engine to understand if it's a particular form, or we also have OCR engines to read scan files and create again. This goes through the analytical engine where we create lineages, we created tag engines, and then we create PI tags, business tags, all these things are created. The analytical engine internally uses the learning engine to using the NLPs or supervised learning or unsupervised learning to create the tags and lineages with as much intelligence as possible. And we also have the data protection engine, and the data protection engine is basically rectification of all your PII classifications. Again, it goes through a approval process to make sure it you have the right security put in place, and security and governance. And naturally, like we also have all the content analyzed and pushed into Solar. Again, not every data have to be pushed, so we have options to determine what data has to go. And again, here security plays a part. So only all your important PII data doesn't go into your content search, so that not everyone can go and search for it. And in data sense, we have the analytical side of it, where we have the analytical engine where you can create cubes, dimensions, and query engines. We have the foundation engine where we create data sets, access points, basically for your security side of it, and data streaming engine to keep moving the data. And we have the learning engine, which we just saw. Again, we have two, the execution engine and execution controller, which I'll say how it's going to work. So overall, I've just stopped with the data platform. I haven't gone too much on depth into the business platform. So with the data platform, again, this is the overall ChainSys platform technology, right? The landscape, where we have your DMZ nodes, which is your standard Apache HTTP server, or it can be any application gateway, be it Azure's application gateway or OCI's application gateway, or AWS. It's cloud agnostic, basically. So we can either go with Apache HTTPD or any other gateway, and that's on the DMZ side of it. Right? So, and we also have the single sign-on to any federated services, SAMLs or OAuth. And then we have the web nodes, basically the front-ending part of it, where we use Spring MVC. And we have the collaborate servers. Basically, this is where you have your emails and your chat information. Like you'll be able to chat against a particular object, so all your chat box stays into the collaborate server. And then we have the API gateway, which exposes your objects in the application nodes as a web service. And on the foundation, we use Redis for caching, and then we have scheduler nodes and file servers to make sure the logs are being published in a very secure way. And the logs also can be published to external for auditing purpose. And on your application nodes, of course, you have your DataZap engine, DataZens, which you have seen. So the basically your foundation tech, we use Java 15, JDK 15. It could be OpenJDK or Zulu or AWS Java or Oracle JDK. So we can use any of it, and then we have Spring Boot as our microservice engine, and then we have Spring internally. So this becomes the foundation technology internally. And other than the foundation technology, so DataZens uses multiple like R, Python, and Dimple.js, and so on. Like there are lots of other D3 Dimple. There are more added. Keeps adding. So may not be able to show everything, but basic informations are here. And we have the Smart App Builder, which uses the foundation technology for all your. Basically, you'll have multiple nodes here or multiple instances. One to do the configuration, the other one to do the deployment node, and then we use Ionic and Angular to create those applications on the fly. And on the data store, we can either go with PostgreSQL or Oracle database. And for indexing, we use Solar, which we have already seen. And for the application data store, we use CouchDB, so that we use Couch as the data store for Smart App Builder, so that your integration, real-time integration to mobile devices would be very as early as possible, right? So it syncs on a real-time basis. So that's where we use Couch for the real-time replication into mobiles. And we also have this is the data again for the metadata store. We have either we use Postgres or Oracle. And then for versioning, we mostly use Git, but we also support subversions if needed. And coming to the deployment side of it, this can be deployed into as we have a public cloud option, we have a private cloud option, we have a hybrid cloud option, which you'll be seeing. We can deploy this on-premise SaaS models also. And when we do an on-premise SaaS model, the each and every node that you're seeing is a separate, can be put into a separate VM, and you can create a cluster of it. And that's why we use HA proxy for internal clustering. Again, HA proxy is just a place where, let's say, for on-prem instances, we use HA proxy, but we can use any other, let's say for Azure's internal load balancers or Oracle's load balancing, AWS load balancers. We can use any load balancing part of it. Finally, we have the hybrid cloud platform. So I was talking about the execution engines, right? So the execution engines are split such that we always have the execution controllers on the cloud, and we can put the execution engine on the client data center to create a hybrid model, so that if for pharmas or finance industries where you don't have to make sure that the data always stays on premise, right, or on their network, we have option to do that. So that's the reason we've split it into as much possible, so that we can use those execution engines as an agent inside the client data center, so that you'll be able to do most of the operations here, right? The same engines will also be available in the cloud engine, so that if you have to connect to a cloud adapters, you will be able to use the directly access it from the cloud. Or if you have legacy systems that needs to be connected from the client side, you'll be using the agents to do that. I think we're almost on time, so I open it for Q&A. Thank you.
Yeah, thank you, Subhash. That was a very informative session on the ChainSys data management platforms. So we have few questions from our participants. So the first question is, can you say more about the ways ChainSys is working to improve the user experience, as well as how AI and ML will become increasingly embedded into the application?
Yes. So with respect to the user experience, right, like we are striving much to make it as user friendly as possible. But again, we are trying to make it as flexible as possible. Wherein in few places, let's take data cataloging or data zen as two use cases, right? Where if we give you a certain default user experience to it, but if you need your own user experience, you will be able to create those user experiences out of the smart app builder, right? So that's why I was saying, see, the way we have architected the engine is everything is a separate component by itself. Everything else is a separate services by itself, right? To put all these things into one single solution, you still can use Smart App Builder as a you can create your own application with these stitching these components that you need alone as a solution. But the way we are improving our solution is we are trying to give you the solutions by default so that you don't have to create your own solutions. So your different solutions like your archival or migration solution or your full EDM, the enterprise data model, data management can be a clear workflow kind of a thing, so that you use you'll be able to experience the flexibility in the
Yeah, I hope that answers the question. So we have one. The next question is: does ChainSys platform host only in cloud or hybrid cloud?
That's why we do host in 4 different manners, right? Like we do a public cloud option where you'll be accessing you'll have a common data or VM pool or common services that will be used by all the clients. But in terms of your multi-tenancy, the database itself is a separate. So you'll have a separate Postgres or Oracle database separately for that particular tenant, so that your data is as secure as possible and there's no leakages possible, right? So we create a separate tenant, database tenant for that particular organization, but your other services are being shared. That is one option. That's the public cloud. Then there's a private cloud option where you have everything separately created for that particular organization, right? And then we have hybrid cloud option where you have the controllers on the cloud, and then you have your own agents put on your end, so that you'll be able to use the so that data stays in your own network. And then we have the fourth option, which is on-prem option, on-prem SaaS option. So we have 4 different deployments.
Okay. So the next question is: what can we expect from ChainSys platform in next 5 years?
Yeah. So we are trying to put as much learning processing, basically your machine learning AI process as much as possible in all aspects of the thing, so that we learn and we start. Already it's a kind of a low code, no code, but we'll be trying to minimize that to make sure that most of it is kind of a clickable events where we give you suggestions and then you go there. So we would like to be on the use the whole data journey for anywhere as part of the ChainSys platform. So we are also making sure that working on the blockchain as one option for all the data integration possibilities to make it more secure and reliable.
Okay. So the next question is: how do you ensure the data is secure?
So when I was discussing, you have multiple options of, there are 2 levels of securing your data, right? One is on rest and the other one is on transit. So in transit, naturally you have your own, like we have the SSLs created, mutual SSLs created, so that your in transit is taken care. On the rest, we go with either database encryption to make sure that entire data is encrypted, or naturally your data encryption will have a kind of a snag at some point in time. So depending on the data set, the importance of the data and data set and the performance, we may determine to say we also have options on the application to determine that we can encrypt only few parameters which will be encrypted and decrypted using the keys that are managed by the clients themselves. So the data is secured on rest as well as on trust.
So we have one last question. How scalable is the ChainSys Data Management Platform?
With respect to scalability, that's where we have everything as microservices, right? So naturally, it's not just one. It doesn't. It's so very scalable that you don't have to always deploy. It's not a vertically increasing thing. So it's horizontally scalable. It's not vertical, right? So you can scale to as many number of nodes, and it's not necessary that the entire platform is to be scaled, right? If let's say you're using the data movement components as highly as needed, then you just scale the or increase the number of nodes in the DataZap side of it, right? Or your number of users in DataZen is too high that you need to increase your DataZen processes, then you start working on increasing the DataZen side of it. So it's highly scalable and highly distributable, that you'll be able to scale to any number of things. There are clients where we are moving at least 200 million records day in, day out on a day-to-day basis. So that's how scalable it is.
Thank you, Subhash. Thank you for taking the time to go over the ChainSys Data Management Platform. And I would like to thank you all for your participation in the session. Hope to see you all there. Thank you again. Bye.